Okay, we are going to take our notes on energy for life. This is coming from Discovery Education, the Living Earth book, Unit 2, Concept 1, Explore page number 2. Okay, this is something that I'd like to see you guys integrate into your notes just for your reference. Make sure you put the date. The essential question is going to be that question in green. What are kinetic and potential energy? Which you know something about because we've already discussed this previously when we were looking at kinetic and potential energy in our physics text. So write down what you know or what you think, okay? Okay, well, hopefully you took a moment and just simply, without referring to the notes that are visible here, just from your own knowledge, had jotted down a few things because that's the key, right? That's why we have you do what I know. That's why we have you do summary paragraphs. We're looking for recall from your brain, right? Without referring to anything. That's how we get this stuff to stick. So, Roman numeral one, we're taking it from this black kind of title here, kinetic and potential energy. So go ahead and write that down for Roman numeral one. And we've kind of, in our own words, taken the text. Kinetic energy and potential energy. You find that energy exists in usually these two forms, one or the other, right? And if you've ever wondered um, if you're going crazy because there seems like there's all these different types of potential energy, you're not going crazy. There are a variety of forms of these potential energy, which is, you have chemical potential energy, gravitational potential energy, you have mechanical potential energy, and the same can be said for kinetic energy. We use the abbreviations. Ke is for kinetic energy, Pe is for potential energy. Okay, you should be comfortable with those abbreviations. Kinetic energy, of course, as we move on here in our notes, number one is often called the energy of motion. Anything that is moving will have kinetic energy. Now, there's a more precise definition. You see it here defined: the work needed to move a body of a given mass to its final velocity. Remember, velocity is speed with a directional component to it, right? So they say or speed in a given direction. So make sure you memorize that, okay? Understand that. We come across the term thermal energy as well. And thermal energy is a term used to refer to the heat that is generated by the kinetic energy of atoms and molecules. Okay, so when you have atoms and molecules, they are moving, they generate heat. Okay, so we often will refer to this as thermal energy. Another term that you should be comfortable with is this idea of temperature. This is, I'll review again. Temperature is simply a measure of this kinetic motion, right? Um, if you have cold water, the molecules of water are moving slowly, and we stick a thermometer in there as a way to gauge how fast those molecules are moving. And we say it's moving at 35 degrees Celsius. That's just kind of a way that we kind of indicate the movement. Now, if it's boiling water, our thermometer is going to reflect that. It's going to be 100 degrees Celsius or 212 degrees Fahrenheit, right? So our thermometers are used to measure temperature, which is a measure of the kinetic motion of molecules, whatever the liquid is, or air. Potential energy, PE, it's the energy we say that is stored, right? We often say it's stored energy. Now, this is important. I haven't highlighted it. That potential energy can be based on your position, right? If you're standing at the edge of a swimming pool and you jump into the water, you'll create a splash. But if you go higher, you go up to a diving board and jump off the diving board, you're going to have more stored energy because you're higher up. You're going to have greater potential energy. You're going to create a bigger splash. Isn't that what we all want to do in life? Create a bigger splash. Haha. Anyway, different types of potential energy. You have kinetic potential energy. You recall that that is the energy stored in bonds, right? Between molecules. If you have a water molecule, you have hydrogen atom bound to two oxygen atoms. There's a attractive force between those that's keeping them attached together, and we call that a bond. Okay. In your body, adenosine triphosphate, ATP, you can see the notation here on the left, is considered a high energy molecule. A lot of energy is stored in that adenosine triphosphate um, molecule. Now, whether a energy is released when you have a chemical reaction, um, in that case, you're actually forming bonds. And when bonds are formed, energy is released. When bonds are broken, energy is actually absorbed in that case there. Um, these two things happen during chemical reactions. Okay, so when we talk about chemical potential energy, we're talking about the chemical energy stored in these bonds, and we talk about things as being um, exothermic. We jump right down here where things energy is released. Okay, and remember, if it's being released, that means that you are forming bonds. And we sometimes talk about chemical reactions as being endothermic. Right, you break a instant ice pack and it feels cold. Why is it feeling cold? It is absorbing energy from your body, which means that it is breaking bonds inside that packet, right? When you broke the little liquid packet in the instant ice bag, it mixed with some other chemicals. And it was breaking bonds and absorbing energy as it was doing that. And that energy was coming from your body, right? That's why you felt the cold. All right. Let's keep on moving here. Other ways to store energy. Um, you know, rubber bands, right? If you pull a rubber band, you know that if you let go of it, that rubber band is going to shoot away, right? It's going to try to go back to its original position. So the more you pulled on it, the more energy was being stored because of its position. We call that mechanical potential energy. Springs are very similar, right? If you squeeze a spring together, you know it wants to release that energy. That is a form of mechanical potential energy. And lest we forget, go back to this first one here, um, your gravitational potential energy, right, is something we talked about with the diving board example. It is related to how far away you are from the center of Earth. And for our experience on Earth, we usually measure that as height, right? How high you are off the ground. Well, I hope that that was helpful. Um, Make sure you watch the videos. Okay, I can't. And make sure you click on these different words. Okay, remember that these words, they have all kinds of useful things. They have animations and they have videos that go along with them and images, and they give you detail on the vocabulary word stuff. So make sure you click on those things there. Okay. See here, you got your images, you got your videos, you got extra details and context and history on the word. And that's it. And I think I just messed things up there. So make sure you write your summary paragraph. All right, we'll talk to you soon.